You know the device you're watching this on right now? Or maybe the headphones you're listening with? What if I told you they're all being powered by a force you literally can't see? Well, today we're going to pull back the curtain on that force, the amazing and totally essential phenomenon of magnetism.
So what is this invisible force we're talking about? I mean, it's way more than just a magnet sticking to your fridge, right? We're talking about this same force that lets a massive 300-ton train float above its tracks. It's the same force that stores the data for the video you're streaming this very second. It's just, well, it's physics. And believe me, it is everywhere.
All right, first up, let's look under the hood. We're going to get right down to the nitty-gritty of what this force actually is and what makes it tick.
So, believe it or not, at its heart, magnetism is actually pretty simple. It's all about moving electric charges. Seriously, just picture these charges as a bunch of teeny tiny spinning tops. Now, when they all start spinning in the same direction inside a material, bam, they create this powerful unified force field. And that field is what gives magnets their power to either pull things closer or push them away. It's also why something like iron, which is just packed with these perfectly aligned charges, reacts so strongly to magnets.
Okay, so if moving charges are the key, what keeps them all lined up and moving together? Well, that brings us right to the source of it all, the magnet itself. Let's take a closer look at what's really going on inside.
To put it simply, a magnet is just any object that creates its own persistent magnetic field. It's pretty cool, right? It doesn't need to be plugged in, it doesn't need batteries, its power is just there. It's constantly radiating this invisible field of influence all around it.
And this is where it gets really interesting. See, every single magnet, I don't care how big or small, has two different ends, a north pole and a south pole. But here's the crucial part, the big rule. You can never have one without the other. You can't. Go ahead, try to snap a magnet in half to get a lonely north pole. Guess what? You just end up with two brand new, smaller magnets, and each one has its own north and south pole. It's like a fundamental law of the universe. Pretty wild.
So, you've got all these north and south poles out there. How do they actually, interact with each other? It's not just random chaos. Turns out, there's a really simple, super predictable set of rules for how this all works.
And this really says it all, doesn't it? It's the #1 rule of magnetism, the one you probably learned in school. Opposites attract, and like poles, well, they push each other away. You can almost see it here. The magnetic field lines just naturally flow from a north pole to a south pole, pulling them together. But try to force two north poles to meet. Their fields just clash and push apart. So simple, but so powerful.
And that whole area where all this pushing and pulling is going on, that's what we call the magnetic field. The best way to think about it is like an invisible bubble of power surrounding the magnet. You can't see it with your eyes, but that's where all the magic happens. And of course, the closer you get to the magnet, the stronger that field becomes.
Okay, so we've got the basic rules down. But how do we go from this simple idea of push and pull to, all the amazing technology that runs our world? Well, let's take a look at magnetism in action.
And the applications are literally everywhere, and I mean often in places you would never even think of. Magnetism, that's what's spinning the motor in your kitchen blender and in a high-tech electric car. It's how your speakers turn electrical signals into the actual sound of your favorite music. They're just using magnets to vibrate a cone. And get this, it's even how old-school hard drives store massive amounts of data, just by flipping the north-south direction of tiny magnetic bits to stand for ones and zeros. It's wild.
And let's not forget the OG of magnetic tech, the compass. A compass is really just a tiny magnet that's free to spin around. So why does it always point north? Because our entire planet is a gigantic magnet. No joke. That little compass needle is just lining itself up with Earth's huge magnetic field. And that same field, by the way, is so powerful it acts like a shield, protecting all of us from nasty radiation from the sun.
Now, electric motors. These things are just pure magnetic genius. Here's how they work. They use electricity to create electromagnets that can be switched on and off, like, super fast. This creates this constant, relentless cycle of attracting and repelling against other permanent magnets, which forces a shaft to just spin and spin and spin. That simple push and pull we talked about, when you scale it up, that's what drives, well, pretty much everything in our modern world.
So, here's the bottom line. It is absolutely not an exaggeration to say that our world would grind to a complete halt without magnetism. I mean it. From the gigantic generators and power plants all the way down to the tiniest little electronic parts in your phone, magnetism is the silent, invisible engine that's pushing it all forward.
Kinda leaves you wondering, doesn't it? I mean, we've already used this totally invisible force to build the entire modern world as we know it. But when you start thinking about the future, things like fusion energy, or quantum computers, or even traveling to other planets, it becomes crystal clear that magnetism is going to be right at the center of all of it. So the real question is, what are we going to build with it next?